All right. Good morning, good afternoon,
Sure.
good evening. We have people are here from different parts of the world, and I want to welcome you all for joining us and taking the time to join us. I know it's summertime and it's tempting to be outside and not sit in front of a camera, TV, but I appreciate you all joining us. I'm Krishna Vidula from India, from Indo Universal Collaboration for Engineering Education. And as you can see, we have a common theme with all our speakers, that is really to find creative ways to improve the way we educate our future engineers and future talent that's going to have to deal with all the stuff that's happening around us. So Michael DeBlasi, okay, let me introduce him for a few minutes here.
Yeah.
He is currently the Associate Manager of Technical Training and Senior Instructor for the START Manufacturing Workforce Development Program at Tesla Gigafactory 1 in Sparks, Nevada. He serves on the faculty of Truckee Meadows Community College in Reno in the Advanced Manufacturing 4.0 program, and is a chair of the advisory board. Since he has an undergraduate degree in physics and a master's in management and leadership, that's very important. Facilitating organizational change, I think that's really the key to a lot of things that we talk about. He held a CTE teaching certificate in technology in Washington State and has taught every level of STEAM from primary school to community college. Wow, university graduate programs, including industry and consulting roles. That's a wide range of teaching and learning experience. Designed several training labs and learning environments for teams as large as 3,500 unique users, filling hundreds of roles. So his career purpose is to develop and deliver career advancement programs that work perfectly for students, instructors, academic institutions, and industry. And we look forward to hearing him share his experiences so that we can all work together on our common mission here. Okay, so over to you, Michael. Real pleasure to have you here, and let's go at it.
Okay, thank you, Krishna. I appreciate it. Yes, so Michael DeBlasi here. Just to summarize again, my current role at Tesla, and I work at Gigafactory, is really talent development. I'm in the education program, but my job is to build pipelines. Currently, we have over 7,000 employees at the Gigafactory in Nevada. We partner with Panasonic, which makes our batteries, which is part of the same building. They have about 5,000 employees. We expect to double the size of that building in the next 5 years. So we need 5,000-6,000 more people to come work for us. And it's always been a struggle to get good talent in technicians, engineers, and any kind of the sciences. And we're a very progressive company. So what we did when Model 3 rolled out, we did this program START program. It doesn't stand for anything, but we had to develop technicians who could work on electric autonomous vehicles in 2018, and there just weren't any people like that around. Current community college programs took 2 years to get them through a program, and then they would go work at a dealer and wash cars or move cars around, right? So you're talking about maybe a 2.5, 3 year program to get them into a technician role. We couldn't wait that long, so we turned that 2 years into 12 weeks of full-time education. I was one of the first instructors in that program, and after I did it for a year, I said, this really works. We can take education and reformat it for it to be as effective in a shorter calendar period to meet the demand. So that's kind of the gist of how I got motivated on to working at this. Tesla has been kind enough to let me work at a college. So I actually have an office at Truckee Meadows Community College, which has a very advanced 4.0 manufacturing lab that they teach students. So we have a partnership where we send Tesla employees to the school that take the program, and then they move up from production to technician to engineer. So it's something we've been doing for a little while here, and it works pretty well. So I'm sharing that idea with people, and it can be a resource to see if that's something that can also be used for industry and education. So yeah, I used a catchy title here, Full Steam Ahead, for my presentation. I'll go through this probably about 10-15 minutes. If you want to put questions in the chat, that's fine, and we'll get to them. But we'll have at least 20-25 minutes of discussion. I want to hear, this is more about hearing from you than me presenting. So let's take a look here. Okay, I did put a little survey in the chat. If you are a student right now, I kind of want to get some information about your undergraduate and graduate experience. If you can fill that out, great. If not, that's okay too. Okay. Okay, so as manufacturing goes through a renaissance in North America, manufacturing is starting to come back here, and we need to staff up for that, right? We're struggling to find talent, and this is across the industries, right? There are great programs in schools at the primary level, community colleges, universities, but they just can't keep up with demand. They're too slow, right? So is there a better way to create a pipeline of technical talent that can keep up with demand? Okay. So let's look at the current environment, right? I'm calling it the 16-year cycle, right? So you go to school, we have you sign up for 16 years, right? To get that degree. That's a long time, okay? So what I'm saying is, during high school, build and break things, right? Put them together. Don't ask why, just make things, right? After high school, then you've got to fix things. Some of the best engineers that I meet and work with started out as techs. And if you look at the great inventors of our time, you'll discover that most of them started out fixing things. You know, they were just tinkerers, right? And from that curiosity came design and engineering, right? So it's always good to have that hands-on part. And I think you get the hands-on part before you get the theory, and I'll talk about that in a little while, right? So the way I was brought up, I always had stuff all around. So I had racing cars and train sets and Legos and erector sets. I mean, my house was littered with all this building stuff, and luckily my parents and family supported that mess, right? But I still base a lot of my success on a lot of the things I did when I was young, as I built all these things and figured out how they worked. Okay, so I learned the 4 things we do in START. We do mechanics, electronics, tools, programming, and fabrication. That's the big 5, I call them, and that's what we focus the program around. I've got a few stats here of how many people graduate college. I think this is a couple of years old. So the majority of college graduates are STEM, right? So about almost 20%. I'm getting close to 1 million people graduate, right, a year. That's a lot of people, right? Followed by business and healthcare, right? So 9% of STEM graduates just get an associate degree, right? So at community college level. 2% get bachelor's degrees, right? Most go on to a master's degree, right? So most take that extra few years to get a master's degree, and then about 10% get a doctorate or another professional degree. So in the STEM program, we tend to take a lot of school, and that's good because there's a lot of things to learn. But as engineers, you know, a lot of our expertise is to make things efficient, right? So how can we look at education and make it just a bit more efficient? It's very effective, but we need to click up the efficiency. Wouldn't be a presentation for me if I didn't put something from Elon in here, right? So when something's important enough, you do it even if the odds aren't in your favor, right? You're the magicians of the 21st century. And a lot of what we do as engineers is very close to magic, right? And then it's possible for ordinary people to choose to be extraordinary, right? So school, good education and good school unlocks human potential, right? And I truly believe in that, right? Okay. So again, talking about the skills that we should have, I say for engineering, right? So fundamental is mechanics. It's interesting how many graduates I have from pretty significant universities in engineering that don't have really good grasp of how to use basic tools, right? They haven't done a lot of assembly. They haven't done a lot of hands-on work, right? So the fundamental of building is tools, right? And there's lots of tools, right? So tools, properties of materials, how to assemble things and take them apart, fasteners, how things are held together, very important, and the forces, right? So that is what we try to teach first. That's kind of the fundamental. If you don't know that, it's hard to build things in the real world, right? And then we go into electronics, because I call that the invisible. Electronics is really hard for people to understand. I mean, I found out. Ohm's law, you explain all this stuff, you do the math, and they say, yeah, I understand it. But then you put them in front of a real panel, or you put them in a complex system, and it breaks down. So we do electronics 3 times in the program for them to absorb it, right? So I teach systems, sensors, feedback, measurement. You know, what does the electronics do rather than, you know, how many ohms is this or how many volts is this, you know, which is important, but it's kind of what does electronics do for you? What is the action that comes out of it, right? So we do a lot of projects in building electronics. Everything is programming, right? Everything we have is controlled by the computer, right? So we do have to do some programming, but we do that later, right? I see a lot of tracks now where programming is first, right? Start coding first. Well, yeah, it's important to start coding first, but what I'm finding out, especially with some of the younger students, is they just get stuck in coding, and they're just coding, and they're never making anything, right? So, or they're making very little things in relationship to how much time they're spending writing code. I do think one of the things that AI is going to do is going to start to replace program. I think AI is going to start to program, especially basic stuff. It will do it very efficiently. So programming is going to change in its importance, I think, in the near future. That's going to be a trend, but we do teach the programming after we teach the fundamentals. Like you know how to do the fundamentals. Now, how can the computer control that, right? And then so we put automation, robotics. We have a lot of robotics in the factory, so we teach that specifically, conveyance. So we teach PLCs, all that in relationship to the mechanic and electronic systems. And then for maintenance techs, and especially engineers in startups, which I don't know if we can call Tesla a startup anymore, but we're always changing things, right? You're going to have to do prototyping, right? You're going to have to build new things and test them out. So to know how to work in the machine shop, definitely 3D printing. You know, it's amazing how many of these high school students I work with have a 3D printer in their bedroom. You know, it's $500, you know, cost of half of an Xbox or a PlayStation. And they're fabricating stuff, you know, as high school students and selling things, right? So you have to know how to make custom objects and modify things to be a good development engineer, be a prototyping engineer. So those are the key skills that we focus on. The way our program's laid out at TMCC, we basically do a 3-credit course in a week. So we have it's 40-hour a week, it's full time. And we do, right now I'm doing 10 weeks, and they get 27 credits in those 10 weeks. So basically what would take them, you know, almost 2 years to do, we do in 10 weeks. So it's very, very high speed. Okay, let's see, am I back? Okay. So as far as the timeline, kind of the way I laid out very simply, so the first thing you do is hands-on, right? So you prepare by reading, doing research, and what I call building breaking. Right? I mean, what do kids have really fun doing? Like running their RC car as fast as they can into the wall, you know, and see if it breaks, or going off the biggest jump and watching it tumble. They love that stuff, right? And there's a quote, I didn't put it in here for somebody, that the best way to learn how things work is to break them, right? So the first thing you do is build things and break them, right? In a risk-free environment, right? And then after you start breaking things, then you start thinking about it and say, well, why did that thing break? Right? How do I redesign it so it doesn't break next time, right? So you start to ask why, you know, looking at the system, right? Then after you've kind of asked those questions, then you start to apply the science, right? Then you start to say, oh, well, if I need to figure out how to make this better, I need to know this kind of math, or I need to know this kind of chemistry, or I need to know this kind of property, right? So create the curiosity, then put the theory. We kind of do that backwards, right? We front load the theory. And I know when I was in, I started out in engineering as an electrical engineering school, and then I went to physics because I thought it was more fun. But the dropout rate for engineering in my day was like 50% the first year, because let's face it, it was boring. I mean, people want to get their hands on stuff, right? So a lot of people didn't make it through that first year because it was so heavy on theory, and there just wasn't enough of the fun stuff. And it's very hard work too. A lot of concentrated math, the calculus, all that stuff drove people bananas, right? I mean, I'd love to ask people, how many people use calculus on their day-to-day, right, as engineers? Maybe some, but you know, we teach a lot of this stuff academically, but what do you really use when you get out in industry, right? And we have a lot of tools, right? So once you're able to do this, then how do you work in a team, right? You very rarely work by yourself, and your teams are distributed, right? They're not people sitting next to you, just like this call. In Tesla, I work with people all around the world every day, right? How do you work as a designer, an engineer, a tech, with a distributed team, right? So that teamwork is really important, right? So you get the team to go on, and then I call it game on, and something that we're working on, we haven't developed yet, is that the final part of the START program is a project, right? You build something as a portfolio, which was kind of in fashion when my son was in high school, that they built these portfolios in high school. It was part of their deal. And I thought it was a great thing, but then that kind of faded away because it was either too much work or something. But any program should have a capstone project or some final project that you can demonstrate and say, I built this. Look what I built. And that's to me, that's worth way more than any resume as far as trying to convey what your value is and what you can do, right? I do. I probably hired 500 people this year. I do a lot of interviewing for tech roles, and it's interesting. Sometimes tech people have a hard time putting down in writing what they know and what they do, but if they can show me something that they built or explain something that they've constructed, then I can say, oh, I know what you're doing, or I know what you know. So this is kind of a brief framework of how we kind of turn the education around from going right into the lab first, getting curious, and then starting to study the theory, because then you know why you're studying it. And adult learning theory is you have to have a reason to learn to be motivated. If you don't have if you don't know why you're learning something, you're just not gonna put the energy in it. You're not gonna keep it. So creating the why first, and then going into the how. Okay, let's see. So a little bit about the START program. Again, solve the challenge to create an autonomous electric vehicle service team rapidly, right? Took a 2-year program and completed in 12 weeks. We partnered with the schools, and at the beginning it was difficult because we were changing their model, but we kind of sat off to the side. We kind of had our own classroom. We did our own thing. In the beginning, we didn't give credits. We just kind of got them through the program. But the school, and we'll talk about the school's financial model is credits. That's how they make their money, right? So we had to build those together, right? The cool thing about the first START program is the cars were the lab. So I had 6 cars. I had 2 Model X, 2 Model Y, 2 Model X, 2 Model 3, and 2 Model S cars. The Y hadn't come out yet. And so basically the lab was fun. They got to work on the cars. They got to drive the cars, which is a lot of fun. And they were pretty much working interns. And then on the weekends, they actually went to the service centers and worked. So they were really learning 6 days a week. And they were fine with that. We paid them to do that. Tesla paid them. They were hired as full-time employees. And then right afterwards, they graduated on Friday. On Monday, they went to work. So it was a seamless transition from school to work. And we had in the school program interviews and everything built in. So as soon as they got out, they were ready to work. And I think that's another challenge we have with education, is that you go to all this school and then you have to go through this process of trying to find a job, which can take a while depending on your situation, right? So we've kind of tied the two together, right? We also have a mentor during the program, which was me at the beginning, and now I'm training other people. But in this cohort, I get to know these students really well, and I'm talking to them all the time. So when they hit a speed bump or they have an issue, I'm right on top of it. In this program, there is no slack to get behind. If you get a week behind, you won't make it. So you have to have somebody who's watching them all the time and making sure they're going to succeed. And that's a bit of a luxury as far as education, but for people to have a mentor in a program is really important. And then also to build the cohort that they teach each other and support each other is also very important for the success. So that's kind of the model that we use. Okay. So how does academics work currently, right? Credits and seat time. Basically, when you go to school, you pay by the hour, right? You take a 4-credit class, it's $500 a credit, it's $2,000, right? You pay by the hour, right? You can only buy it in set quantities, right? You can't say, I want to buy 7.5 credits this quarter. Nope. You got to buy 3 or 6 or 9 or 12, right? It's set, right? Plus the schedule is set, right? COVID has changed things a little bit, but in my day, if you took Physics 101, it was Monday, Wednesday, Friday, 10 to 12, and that was your choice. And that's when you showed up, right? If a section is full, you're out of luck, right? You got to wait till next quarter, right? And then transferring credits, if you go to, especially if you're going to a community college and transfer to a university, they say that the credits will transfer, but a lot of times they don't. And that's very discouraging for the students, right? So that system is something that needs to be worked on, right? As far as instructor, you kind of get one choice. The instructor comes with the package. You can't choose what style or what instructor you want. Most of them are set in their way of how they teach, right? A lot of the instructors don't have industry experience or recent industry experience, so they can teach the theory, but can they teach what's going on in industry, right? I am lucky. I'm working in industry and teaching at the same time, which is a good benefit. I can tell them exactly what's going on in the factory today and what they need to know to learn, right? Grading bias, I probably should have worded this differently, but how the instructor grades is a lot of how the class is, right? Some do on a curve, some do other things. So however the grading is, which is very important to students, everyone wants a 4.5 GPA now, right? So how the grading works affects your approach to the class, right? And then if you do have a challenge with the class, who can you go to, right? Usually you can't go anywhere, you're stuck, right? And it can be kind of stagnant, right? The other model for academics is what I call the terminal degree, right? Keep going till the end, right? Don't stop to get a PhD, right? Getting multiple master's degrees, right? I put the question there, is it really worth it to get a PhD early in your career before you've gotten some industry experience? Something to think about, right? I'm a lifelong learner, and I probably believe that most people on this call are. So, you know, we all have terminal degrees that we learn until we end our life, right? But it's a combination of your self-study, curiosity, your employment learning, and your formal schooling. So I think that combination of learning is really what makes things strong. And then, misspell there. And then the best way to learn, obviously, for me is to teach. So if you can teach while you're learning, that's a good thing. So for me to work at the factory and be an instructor is a great benefit. So I encourage students to go into internship programs, and my internship program is in the education department, which is kind of rare. So my interns come in and I have them not only learn engineering, but have them teach my classes, which is a really good experience. So again, looking at the current economic model, academic model, it works. We have a great school system, great educations around the world, but it needs to change a little bit to adapt to industry. Just change a little bit. Okay. So summary, we need talented engineers and technicians to sustain this industrial and technical growth acceleration of the modern world. Our school system is very solid, but it really can't keep up with the pace, right? So we need to try to re-engineer our technical education to keep up with the demand. Okay. Provide the best talent that we can and the best opportunities for people. So that's what I got. All right.
Oh,
so
fascinating. Good job.
Let me open it up to the floor and tell me what you got. Here's my contact info. So here's my TMCC email and the link there. I can put it into the chat. That's the start page for Tesla, and you could look at the START program and how we recruit people and what's going on, just to kind of look at that model. So yeah,
Great
let's.
job, Michael. Fantastic job. I really appreciate, short and powerful. So it's something that I'm sure will generate a lot of little discussions with our participants here. Start putting things in your chat box or raising your hand as you find appropriate. But while we get people to start getting warmed up, I'm already warmed up, so I'm going to ask you a few have a little comments and questions here for you. You showed a slide where you talked about the 4 stages from mechatronics to electronics to programming and then finally fabrication. So that sequence is just very powerful, because that's kind of what I think a lot of engineering colleges, a lot of institutions are moving in creating spaces, what they call maker spaces, where engineers from students from all disciplines are encouraged to go in there and create stuff, and because that's really how learning happens. And so, and in India also, we're trying to encourage most of the colleges to have those kinds of spaces. So that's one area I'd like you to comment on in terms of are you seeing that happening more and more in different places, and how have you been able to help facilitate those processes? And the other thing, of course, is just the whole thing about the electric vehicle, taking it from 2 years to 12 weeks is just amazing. And it's and I think the future is, in fact, in condensing education into short things, rather than 4 years to do it in whatever X number of months or something, and get them ready, and they come back and teach and learn all kinds of amazing things that you have brought up for us. So quick comments on what I just said, and then we'll let other folks who are ready to jump in.
Yeah, I posted something in the chat. So UNR, University of Nevada, Reno.
Please go ahead. Yeah.
Tesla has contributed quite a bit of money as part of their agreement to move into the area here. And we have something called the Innovation Center. And that's spelled correctly for Nevada, Innovation Center. And it was built with in partnership with Switch. And it's basically a very sophisticated makerspace that's off campus that the students have access to. It's staffed by students. I have brought my people down there. It's got a full 3D printing lab. It's got laser cutters, CNC machines, a whole shop, sewing. You can rent out little spaces for innovation. There was a student group in there that was making artificial limbs for animals in there. So at UNR, if you look up this innovation center, that model is what we're doing. So we're building this extra space for builders that has the equipment there and training. It's actually open to the whole community. It's free for students. It's like $10 a month. It's like a gym membership, but you have access to all this equipment. And I think that this is a trend that's going on, that they're building these kind of external maker spaces in partnership with universities, so that people have a space to go in and create stuff outside of what the lab capabilities are of the school.
Okay, let's see. Raju, did you want to say anything?
Yeah, sure. Michael, thank you very much. You provided a very insightful, true picture of the educational system in US. Do you share this 12-week program? Also, that Panasonic you mentioned, do they also have access to this program?
No, right now it's just Tesla. Panasonic has their own education program. I think it's very unique. I'm doing research, and that's why I want to ask. I don't know if anyone else is doing anything similar to this that I've seen out there.
Are you willing to share this 12-week model with some of the community colleges? I'm in Kansas because Panasonic is putting a battery factory in Kansas City with that $4 billion investment there. So that I was wondering, that I'm excited to learn about this 12-week model.
So what we do, our model is we are partnering with different community colleges. So I'm just wrapping up with TMCC, and I'm going to move to another college down in Carson City, a little south of here, and set up the program. So we have a few people around the country that are setting these start manufacturing up. We have one in Texas, in Austin Community College, that feeds the Gigafactory in Texas. We have 2 schools in the Bay Area that are helping with Fremont, with the Fremont factory. Diablo Valley College is one of them. So we're really just starting to roll this out. We just have a handful of schools right now, and we are looking for schools that want to be partners. So if you're at a school that wants to be a partner, then reach out to me and we'll talk and see how we can get the program going. Of course, we'd like to have it be for Tesla, but if you expand it to another area, we're all in this together, I think. So I don't think it's something we've patented really. It is a unique program, but I'm definitely willing to talk to other schools that want to partner and talk about the experiences we've had, because it takes a while. Academic has a cycle. Most of the times when we start conversations, it takes at least a year for a program to get started. So we can start talking about it. I come to visit, I come to the school, look at your stuff and do an evaluation, and we can write a little plan and say, how would you get to the right environment to support this kind of a program?
Great.
Thank you.
Eric, you want to jump in? Looks like you want to jump in.
You know, I was curious. You mentioned earlier in the presentation that AI is going to change things within programming and that type of stuff. How are you looking at how the START program evolves in terms of training those fundamentals, the PLC programming, the robotics, that type of stuff, with now AI as part of that?
Well, it's a good question, Eric, and it's all so new. I have to say, I've kind of put it to the side. It's like almost too much to handle for me right now with what I'm doing. I've just been watching out of the corner of my eye, but it's amazing how just casual conversation with everybody, how people are using AI. So it's coming quickly, but I think like with every new technology, we're not quite sure how to use it yet. We've talked about how to put AI into the START program, but we haven't really set anything up yet that I would say is gonna roll out anytime soon. So we're on conversations, but we're not quite really sure yet how to do that for the START manufacturing. We are working on a more focused engineering program, which probably will have a bit more AI, at least understanding AI component to it. But we kind of have our hands full with what we're doing now, and it's working, because again, it's a lot more of the physical world. So AI can't change that too much yet. But in the programming world, I think it will make a big splash sooner than anything else. But we haven't determined what that would be yet.
Okay. Lydia, you look like you want to talk a little bit. Did you? Lydia, time 6 in? No?
Yeah.
Yeah,
Krishna,
yeah, go ahead.
I have one more question.
When Lydia is trying to talk, hang on a minute.
Okay, please. Yeah.
She's in 2 places. Yeah, go ahead. Now you go ahead. Yeah, Lydia.
How long is this training that you are now offering?
How long is the training? Is that the question?
Right.
Yes,
So,
yeah.
so
My question is there, this stream that you are offering, for how long is this? The
So
training?
it's right now we're doing it in a 10-week block. We do it in 10 weeks. And right now we have we're doing it 3 times a year at TMCC. So we're almost to the point where it's going to be continuous. Like we'll have cohorts going pretty much continuously through the year for these schools, because we have the demand. The cohort size is anywhere between 12 and 16, which is about the load based on the equipment we have and what an instructor can do. So we're looking to put out, maybe 50 students a year per organization, 50 highly qualified students per year at each school. So in a 10-week program. In Texas, the program is 12 weeks because they do a little bit more emphasis on robotics, because they're a little bit heavier on robotics in the Austin factory, because that's where they build the cars. So they spend an extra couple of weeks on the robotics there. So each school, each area may change a little bit, but I go to a 10-week because it fits into the school cycle really well. And so I have to think about that. I have to try to make this program fit into their semesters for enrollment and all that stuff. So 10 weeks, anything between 10 and 12 weeks works pretty good for a quarterly cycle. And we actually have one, I just had a cohort start last week. We're doing a summer session, which is interesting because the school is closed in the summer. The school doesn't have any classes in the summer, but we convinced them to say, hey, we're gonna do a summer program. So we were actually doing a summer program while there's nothing else going on. So we're actually helping the school utilize their, talking about sustainability, but why have all this equipment sit there? Millions of dollars worth of equipment sitting there. Let's use it. Let's train these students. So it's good. It's a good program. It's good use of resources. Does that answer your question, Lydia?
Yeah.
Okay.
Good, thank you.
Raju, you wanted to jump in again?
Yeah, Mike. Nowadays, with emerging technologies in smart manufacturing, the augmented reality and virtual reality at the shop floor in manufacturing and maintenance is becoming. Do you expose students to those technologies?
Well, we're fortunate at TMCC. We have a Festo 4.0 lab. We actually have a 4.0 lab station that they gave us that we're still trying to figure out how to get the best utilization out of it, quite honestly. But it is a full manufacturing system. It's a full factory, in a room, basically with autonomous robots to move the parts around. It's got a full MES system, PLCs. It's got a robot integrated 3D vision inspection station. So it's a very, very sophisticated piece of equipment, and we're trying to really figure out how to get the best use out of it. I think the intention when they bought it was more for upper division. We actually have a BA program in the community college, so it was more for the 300 and 400 level classes that were supposed to be for engineers. But I see it as a really good tool for maintenance, that we can break the system and have them fix it, because it is a full system. So part of the work I'm doing this summer is to get that 4.0 lab working and integrated in the START program. So we do have the equipment. I think there's only, I don't know if they're telling me the truth, I think there's only 5 or 6 of them in this country. Festo is a German company. We were, I think, the second school to get it. We got it a little bit before COVID, and then everything shut down. So we're just kind of dusting it off again. But it's a very sophisticated system with a lot of potential for technicians and engineers. So we're working on that. But it's, again, it's a lot of maintenance. You have to have the right people in there to make this stuff work. And that's part of our challenges to get the support for this sophisticated lab equipment.
Thanks.
Okay, other comments, discussions, etc.
Yeah.
Before we start. Hans, are you there? Oh, you're there. Okay. Yeah.
Hans there. Hi, Hans.
Greetings. I had difficulties connecting. I was at a meeting of the executive committee here, so my apologies. I'm listening carefully.
Okay, excellent. And if anybody wants to come visit TMCC here in Reno, we actually have a lot of schools come through because we have a pretty good system. You're welcome to come, and I'll give you a tour of the learning labs and stuff like that. So, and maybe I could even do that. Maybe that would be another presentation. I could walk you through the labs virtually. That might not be a bad idea if you can't get here physically. But we had people from Poland here a couple of months ago, and some people from Washington State and California. We have quite a few people come through TMCC because we have a really, really solid program there. And the building I'm in is just tech. It's just the technology center. So it's machine shop, welding, diesel mechanics, automotive, advanced manufacturing, and architecture. So it's the building is just tech, which is really cool. A fun place to be. So yeah, you're welcome to come and visit, and we'll give you a tour. And then maybe we'll bring you by the factory too and give you a factory tour of Gigafactory, which is pretty impressive. So always welcome to have visitors, coming in. So. Anybody else? Oh, good. We've got a few people online. This is great.
Discussion. Yeah. Hans, you can do your thing.
Thank you very much. Michael, it's a pleasure to see you directly here, and my apologies, I had some technical difficulties in the previous meeting. Very, very thoughtful. What comes to mind, and just sharing it with, there are a number of colleagues that I've not had the pleasure to work with and that are participating, Krishna, in this wonderful workshop here today. I'd like to very much make you aware, and I could see you, Michael, engage, and we can have a follow-up conversation and even a follow-up webinar with the host, and I'm co-host of that, of our global conference at Monterrey Tech, Mexico in October. And I just spoke also with him very, very early this morning, and I could see your engagement there without going into details at this particular moment. But I want to mention this not only to you, Michael, but to all of our other participants in the webinar today to think about getting out of our historical and emotional intellectual box and look at other continents and other countries where we have events working literally in 6 continents of the world. Obviously a close relationship and friendship with our friends in India, but many, many, many others. And I'm very, very pleased. For example, I'm seeing a very distinguished colleague and scholar, Dr. Lydia, who is here from the Philippines, who contributed to our book, Rising to the Top, which was written by women leaders throughout the world. So Lydia, I'm just so pleased to see you, directly here participating in that per se. And also another colleague, Dr. Amel Chenov, for example, is here that I'm not from Algiers. I've not had the pleasure to, and I'm very happy to see. And of course, there are many others who I don't know that are engaged. But I wanted to put this information in your minds, and you can reach out to me. And in terms of the Monterey conference this October, we're working diligently. This is a global event, and for you to consider joining us. And this is not only obviously faculty members, but corporate colleagues, deans, and students. And we have a key student leader here, and that is on the webinar today. I'd like to put that information. I'm also very pleased and working very closely the ASCE conference in Baltimore in June. We're bringing together IFEES GEDC members, and if some of you are coming to Baltimore in a couple of weeks per se, I would love to invite you to our sessions there per se. I just last night had a long conversation with a close friend of mine in Nigeria, and we worked very closely with the African community and the conference there in Lagos in October, early October per se. I just wanted to give this very brief update. Thank all of you very much, and Michael, let's stay in touch. Let's consider the possibility of you doing another webinar as such, and I'll discuss this with my dear friend Krishna closely, and hopefully see you and all of us in Baltimore, or certainly in Monterey this October. Peace be with all of you.
Fantastic, Michael. This is not just the future, it is the current. Right now it is here. And what you're doing
here.
is,
Yes, we're doing it right now.
We have to keep up with it. Run very fast. And you're doing a great job. Help us others also to kind of get a little idea how to work with this. And so thank you. Good evening, good morning, good night, wherever from different parts of the world, and peace, everybody.
Yeah. Thank you, everyone.
Bye, everybody. Bye-bye.
Thank you.